Hello, my name is Xiaolin. This is my fundamental of aerodynamic project 2. I'll be working on the Excel part. And let's start with the plot of velocity profile at a different length. First, we go to fluent. This is my fluent. We go to plot, XYZ plot, XY plot, actually. So we're looking for fluid velocity. Fluid magnitude matching y coordinate and 3 different locations. X is 0.25, 0.5, and 0.75. We save and plot, and here's my plot at different location. If I want to save this, we to right to click select this, right, and save the place we want. And here's the file already saved. It's the data from Ansys at 0.25, 0.5, and 0.75. Just copy paste entire data into Excel. I rearrange everything, and that's the y coordinate. This x location, y location. Oh, x. I mean all three x at different location. And we want this plot. We select everything. Go insert, recommend chart. This is the chart we need. Here's the Excel chart, and here's the Ansys chart, which is really identical. This is what I have right here. That is the velocity profile part, and we're now looking for the boundary layer thickness value. We find boundary layer thickness, we find the v velocity at 0.99, v infinity. Using this equation 0.2, 2 is the given velocity we're doing, so we having 1.98, that's the thickness. So we go back into chart at 0.25, around 1.98 as far as 0.5, 0.0052. It's in the table, and same for 0.5. It's really close. We choose 0.0068 at 75 centimeters. We're having 0.008. But we call it the theoretical one. We need the using this formula over here. Uh, the gamma equals x, the location on the plane times 5 divided by the Reynolds number at that location. To calculate the Reynolds number at that location, we use this formula. Rho times v infinity times the location divided by viscosity. Using that, we have 1.2, that's the air density, 2 is the velocity, and 0.25 is the location we are using. 1.8 times 10 to the negative 5 is the viscosity of the air. We get that, we get 3,300, 33,333.33. That's our Reynolds number at 25 centimeters. We throw into the table at this location at 0.25, divided by 5, exactly this equation I'm using. Square root of the Reynolds number, I-27. You just click on this. And we get the Reynolds number at the location theoretically and the Ansys comparison. That's basically for the velocity profile questions. Now we go to the plot wall shear stress and skin friction coefficient, or go back to fluent, semi XY plot. In Y function, we're using wall flux and wall shear stress. Same story, we save a plot. Here's my wall shear stress. We drag down, change to skin coefficient, we use save a plugin. This is my skin friction coefficient. I need to do the same thing, save as file, save whatever you want. And here's the data I got from Ansys of skin coefficient and wall shear stress. Same story, copy paste into Excel. The Y is also from Excel. from Ansys data is the copy of the washers and skin friction. Now we calculate theoretical washers. We're using this formula. Same here, I'm using this formula I'm using inside in this chart. 0.32 times viscosity to the 0.5 power times air density to the 0.5 power times the velocity. That's 3 divided by 2 power divided by A3, which is the location, times the to the 0.5 power. After that, we drag it down, we get all the numbers in different locations. Now we go to the shear friction. A local shear friction, we're using this formula, but we need the Reynolds number again. Same story, we're using the equation from here. Rho times V infinity times the location x, 1.2 times 2 times the location divided by viscosity. You get all this Reynolds number. And back in the skin friction, 0.06 divided by the square root of the Reynolds number we got from, and we will get the skin friction coefficient. Now we make it into a plot. All we need to just select the length, the height, I don't know, the washer, select everything, like insert, recommend chart. Oh, it's not recommend chart. That's weird. Recommend chart. Uh, recommend chart. What? No shot. Oh. Yeah, there it is. This is chart we got exactly the same as this, but there's no extra part, like all of it, a huge drop. Because in Excel, in my formula, this A2 divided by A2 to the 0.5, technically it's power to 0 power to 0.5 is still 0. It's something that would zero get error in Excel. So in my chart, I just ignore the error part. So I got skin friction, same story, select the Y bar and the Ansys and theoretical one datas, and we'll get this chart right here. All right, last not least, get a drag coefficient for the flat plane. Go back to Ansys. We right click on report definitions. We go new, it's a force report, go drag, drag force on plane. You say compute, you get this number right here. 0.00418 technically. And we throw into Excel. Here it is the number. We calculate the theoretical drag force, drag coefficient. CD equals 1.328 divided by Reynolds number of the entire square root of Reynolds number of the entire length, which is 1 meter long. Same equation, 1.2 times 2 times 1. 1 is the length of the plane divided by the viscosity of the air. Nope. And drag coefficient is 1.38 divided by square root of the Reynolds number. We get 0.0036363, which is really close to Ansys simulation, which is nice. Yep, that's pretty much everything I need for the Excel part, and thank you.